Hi, I'm Micah. I'm the creator of the Arroyo streaming engine. Arroyo is designed to be the easiest way to build real-time data pipelines. I started the project because I'd seen how hard existing streaming engines, like Apache Flink, are to use. We wanted to enable anyone, whether you're a product engineer, a data scientist, or a data engineer, to work with real-time data. In addition to making streaming pipelines easier to write, we're also working on making them easier to deploy and operate. Historically, running production pipelines has required complex distributed infrastructure like Kubernetes. But Arroyo 0.11, released last month, included a new lightweight deployment model called pipeline clusters. Pipeline clusters essentially bundle up the control plane and the data plane with your query logic and allow you to deploy that almost anywhere. In particular, it enables you to deploy pipelines to serverless infrastructure providers that can handle all of the operational overhead for you. I want to see how easy it would be to deploy Arroyo to one of my favorite infrastructure providers, Fly.io. If you're not familiar with Fly, it's basically the easiest way to deploy an application in a way that's distributed and globally replicated. It handles all of the complex operational details for you compared to something like AWS or Google Cloud. And I wanted to see just how easy it would be to deploy Arroyo to this infrastructure. I was particularly excited to see a few months ago, they released support for Tigris, which is a globally distributed object store. So you can think of it as like a replacement for S3. And I think with that addition, Fly has become a really great platform for deploying data applications like Arroyo. So yeah, let's get started. Let's see how we can deploy a real streaming application to Fly. So we're going to start running this pipeline locally first so that we can iterate on it and make sure it's doing what we want before we deploy it. The easiest way to do that is to install Arroyo locally. So I'm going to do that using Homebrew. If you're on Linux, you can do this with a shell script we provide, or you can run it on a Docker container. And with that installed, we can just run a local cluster. I can pull up the web UI in my browser. Here we have it. We're going to create a pipeline using some openly available data. If you're running this on your own data, maybe this is your web logs, your server logs, your events coming from mobile applications, sensor data. But for this, we're going to use some publicly available data from Wikipedia. So I'm sure you're all familiar with Wikipedia. It's the global repository of knowledge that we all rely on to write our papers and things. But helpfully, they also have a bunch of open data sets. The one we're going to be looking at is the recent changes stream, which gets published to every time anyone edits a page on Wikipedia or one of the other Wikimedia sites. Helpfully, this is published as an event stream or a server-sent event stream, which is a really simple HTTP-based streaming protocol that Arroyo natively supports. So we're going to create a pipeline here that's going to read from this server-sent event source. A basic version of this source just looks like this. We are setting up the stream, and then we are just parsing it as what we call unstructured JSON, which means we just get to see kind of the raw data here. This is helpful for just getting a sense of the schema and sort of what the data looks like. You can see all these different fields. Then we can go through those fields and we can schematize it. So we can actually create a SQL schema, which might look like this. Here's just all of those fields turned into SQL data types. And then if we preview this, we preview this, we can see all of those fields are now separated out into different columns here that we can build queries on. There's a bunch of things we could do with this data. One thing we might be interested in is who is editing Wikipedia. For example, maybe we'll look at the top 10 editors over a sliding window. That query would look like this. We're using a hopping or sliding window to divide up time into these overlapping chunks. And then for each one of those chunks, we're using a SQL window function, row number, in order to rank them by the number of edits, this count. So if we look at that, we'll see every 5 seconds, the top 10 users are going to be outputted with this row number that ranks them. You see that updates. So this is pretty cool. How can we actually use this data to build a web application? Well, first we need to write it somewhere. For that, we're going to use Redis. Redis is both a great tool in general for powering real-time applications, but it's also particularly great with Fly because they have native support for Redis. So we're going to create a Redis sync. Stop this preview. We'll create this Redis sync that has our output fields. And it's writing here to a local Redis that I have running on my laptop. If you want more details on how all of this works, please check out our docs or the full tutorial. And then we have our query here. I've added a few more fields that might be interesting, like the total diff of the change and whether or not the user is a bot. We can preview that, make sure this is all working. Perfect. So we could run this within this cluster, but instead we're going to use a pipeline cluster. So I'm going to copy this query, open up a new tab in my shell, and I'm going to write it to a SQL file. So I'm just going to copy and paste this here and save this to this query.sql. I'm going to kill this cluster. And we're going to run this using the Arroyo run command, which is what starts a pipeline cluster. So now this is running. It starts up its own local web UI that we can use to see the preview, kind of what it's doing. We have here our graph representation of the pipeline, some metrics. We can see we're reading about 30 events per second off of this stream, and we're writing data to our Redis sync. And we can also look in the Redis CLI and actually see the data. Here's the outputs from our pipeline, which looks a lot like the data we were seeing earlier in the console. So this is pretty cool. You can see it's updating. But the Redis CLI isn't a great user experience if we want to share this data with other people. So we're going to write a web application that's querying Redis and is able to update and show this data. I already have this app here. It's a Python Flask application using the HTMX library. If we look at this, it's pretty straightforward. We're just querying Redis. We're getting our data, and then we're rendering it on our templates. I'm gonna create a virtual env here. And then activate it. Install our dependencies, which are just Flask and Redis. And then we can run our application and look at our local server here. And here's our beautiful web application showing this data. And you can see every 5 seconds it updates with the latest events. Perfect. So this is awesome. We have our application running locally. So the next step is to deploy it to Fly so we can share it with other people. So let's kill this. We can stop our local version of this pipeline. Now we're going to go to Fly. We're going to log in here. I already have my account set up. So there's a few different ways to deploy things on Fly. For example, for the Flask application, it has built-in support for that, which is great. For Arroyo, it doesn't natively know how to run it, so we'll have to give it a Docker image in order for it to know what to deploy. That command looks like this. We're going to use the no deploy flag so that we're able to make some changes to the configuration before it deploys it. We're going to tweak these settings. So we can give it a name. This name has to be unique, so for yourself, you can choose a different name. We'll call it Arroyo on Fly. We can deploy it in my local region, San Jose. We're on port 8000. We're going to use the smallest Fly machine that runs within the free tier. And then we're going to add both Tigris object storage, and we're going to add upstash Redis. So that's perfect. It's going to configure this here. Cool, and now we're ready. Fly creates a configuration when we create the application, and we're going to need to tweak this a little bit. Again, for the details for all this stuff, please check out the tutorial. We're going to need to look up what our Fly Tigress name is, which here is Icy Bush. So we'll use this as our bucket name for our state storage. And then everything else we can leave the same. So we'll close this. Make a couple changes to our pipeline as well. So in particular, we're not going to be writing to our local Redis. We'll be writing to the Upstash Redis that Fly is helpfully hosting for us. And so we can see here the Upstash Redis endpoint is here. So we're going to have to split this up into a few different pieces. Here we have the Redis host name, and we'll just set that here. And then we could put the password directly in here, but that's not very secure. So instead we'll use fly.io secrets, which is able to inject environment variables into our environment. So we'll set the password to the result of this environment variable, which we'll call Redis password. And the username is just default. So now we've changed this pipeline to actually write to our real Redis installation. And now we'll actually create that secret from the password that it gave us here. Secrets set Redis password be equal to this thing here, this long hex string. Cool. And now we're ready to deploy it, which we'll do with this fly deploy command. We're going to set the query using this other environment variable, Arroyo run query, and just using the value of this file that we've created here. And we're going to set HA to false because we only want to run one instance of our streaming pipeline. So this is going to spin up. It's going to take a few seconds to do. And then once this is ready, we can load up the web UI, just like this. Cool, and here it is. We don't need to do the tutorial. We can see our pipeline running and reading data and producing outputs. Now, I do want to say here that this is not the most secure way to run things. You can see like this web UI is available on the open internet. It's great for a demo to get something out really quickly, but to do this for real, we'd want to run it behind a VPN, which Fly also makes really easy, but it's a little bit too complicated for this walkthrough. So now we're ready to deploy our web application to Fly. Fortunately, Fly has great built-in support for Flask. This is super easy. All we have to do is just modify the application a little bit to use the hosted Redis instead of our local Redis. So if we pull up the app.py here, and then we can also open up our query and get that Redis connection information. So here is the host, which we can paste in here. And then for the username, that's just default. And then for the password, we're going to get this from our environment variable, the secret, so that we don't have to hard code it in our text. Perfect. And that's it. That's all the changes we need to make. Now we're ready to deploy our application to Fly. So we're going to do fly launch, no deploys, so that we can set the secret before we deploy it. We'll tweak these settings a little bit just to reduce the resource utilization so we stay within the free tier. We can set this to something fun like top wiki editors. Remember, these have to be globally unique, so you'll have to set it to something else. And then that's set. Once this finishes, cool, and we're ready to set that secret. and then we can deploy. So Fly knows automatically how to deploy a Flask application. So behind the scenes here, it's created a Docker file that is able to build our Flask application. And that's what it's building now, or already built. Now it's pushing that Docker container to Fly. And then Fly will use that container to actually run our application. So we just have to wait for this to finish pushing. And then it's going to spin up some infrastructure, and we'll be able to see our application running. So you can see our new application here, Top Wiki Editors. It's rolling out. They're launching some machines, which are like the underlying infrastructure that Fly uses to host these applications. Now it's deployed, and we can go visit our beautiful analytical website. It updates every 5 seconds with the newest data. And all of this is running in a totally serverless fashion. I think this is really pretty remarkable that we're able to run a complex stateful streaming application in a completely serverless manner, where we don't need to manage any of the infrastructure. If anything goes wrong with our streaming application, it'll get automatically restarted. And because this is all being statefully checkpointed to Tigris object store, even if it gets restarted, everything's just going to come back exactly as it left off. It'll even recover all of the missing data because the SSE protocol is able to kind of go back in time and reread the data that was lost. So that is Arroyo running on Fly. I think it's literally the easiest way to run a stateful streaming pipeline, and I'm really excited to see what folks do with it.